Now that the Math 152 course is halfway over, the second half of the course deals with trigonometry. And really all trigonometry is, it's the relationship between angles and lengths. All right, so not surprisingly, the first thing we're going to deal with in our study of trigonometry is going to be angles and their measures. So an angle, one way to look at an angle is just to kind of not even really define it, just basically say how it's formed. So an angle is really just formed by two rays, right, which are basically parts of lines. And you think of the angle as the degree of rotation between one ray and the other ray. Okay, so what ends up happening is whenever you have an angle, what we're going to do is we're going to call one of the rays the initial side, and we're going to call the other ray the terminal side. So the yellow is the initial side, the green is the terminal side, and then with this one, there's your initial side, and there's your terminal side. And the way that we think of the angle is it's just how much rotation was required to get from the initial side to the terminal side. So in the case of the one on the left here, we actually had to rotate counterclockwise to get from the initial side to the terminal side. So that's going to actually be a positive angle when we rotate counterclockwise. And over here, to get from the initial side to the terminal side, we rotated clockwise, and that's going to be a negative angle. So counterclockwise rotation is going to be positive, clockwise rotation is going to be negative. So you might recall that 360 degrees is one complete rotation, which means then that a quarter of a rotation would be 90 degrees. That's going to be called a right angle. Half of a rotation would be 180 degrees. That would be called a straight angle. And you also had things called acute and obtuse angles. These were all geometry concepts, right? So an acute angle was just an angle that was less than 90 degrees, and an obtuse angle was an angle that was between 90 and 180 degrees. So now the problem with measuring in degrees is that degrees are not real numbers. So we really need some other kind of degree measure that is actually going to be a real number. So what we do is we use what's called radian measure, because radian measure is actually a distance. So what radians do is they measure the distance around the circumference of a circle with radius 1 unit. So you could see in these diagrams down here, what we're doing, especially in the 4 on the right there, we're considering this to be our initial side. And you can think of that as the positive x-axis, right? If you're breaking this thing up into a coordinate plane, that would be the positive x-axis. So we're going to call that our initial side, the positive x-axis, and we're going to refer to these angles as being in standard position. So then what happens is radian measure measures how far along the unit circle, this circle, right, that has a radius of 1 unit, how far along the circumference of this circle you've traveled. So in this case, I've traveled from here to there, and that distance is actually 1 radian. Now in this case, I've traveled from here around half the circle, right? Yes, you can say that's 180 degrees, but when you're dealing with radian measure, half of the circumference of the circle is actually going to be pi. So that was actually an angle that's pi radians. And here, I traveled a quarter of the circumference, and a quarter of the circumference is pi over 2 radians, right? Because the whole circumference would be 2 pi. And the reason for that is that the formula for the circumference of a circle was c equals 2 pi r. So if r equals 1, the circumference is just going to be 2 pi, right? So once around that unit circle is 2 pi radians, which is equal to 360 degrees, right? So 2 pi radians is going to be equal to 360 degrees. And that's really where this next thing comes into play, right? So converting between degrees and radians. So we know, of course, that we just said it. The formula for the circumference of a circle is 2 pi r. So if the radius is 1 unit, the circumference is going to be 2 pi. So this is what I just said before. 360 degrees is equivalent to 2 pi radians. And then what you can do is you can change this around a little bit, right? So if I know that 360 degrees equals 2 pi radians, I can divide both sides by 2. And if I divide both sides by 2, I would get to this, that 180 degrees equals pi radians. If I divided both sides by the whole thing, 2 pi, I would get to this, which is the fact that 1 radian equals 360 degrees divided by 2 pi, which simplifies to 180 over pi degrees. And then alternatively, if instead of dividing by 2 pi or pi, I had divided by 360, what would happen? I'd end up with 1 degree equals pi over 180 radians. So those last two there, this and this, those are the important ones to remember, because that's what you're going to do when you're converting from either degrees to radians or radians to degrees, right? So to convert degrees to radians, you multiply by pi over 180, and to convert radians to degrees, you're going to multiply by 180 over pi. So just a simple example of this then, if you're trying to convert 60 degrees to radians, well, I'm doing this. I'm converting degrees to radians, so I'm going to multiply by pi over 180. So I'm going to say 60 degrees times pi divided by 180. Well, 60 over 180 is really 1 over 3. So 60 degrees is going to be pi over 3 radians. And then if you're doing the reverse, right, if you're converting from radians to degrees, how many degrees is pi over 6 radians? Well, you're doing this second one, right, radians to degrees, so you're going to multiply by 180 over pi. So pi over 6 times 180 over pi, what's that going to equal? Well, again, I can do cancellation here. 180 over 6, 6 goes into 180 30 times, and the pi's cancel. So I would just have 30 degrees. So pi over 6 equals 30 degrees, and 60 degrees is pi over 3 radians. So that's just, using that conversion factor, right? Multiply by pi over 180 or 180 over pi.